Okay, so 3 and 4 are good ones for us to work through. We are going to discover something as we do this that is very, very useful in the world of trigonometry. Something that's already so useful it's on the wall. But let's find our way there on our own. So number 3 says that the y-coordinate of a point on the unit circle is 3/5, 3/5. Didn't we do this yesterday? We did do this, right? Okay. So this is x 3/5, and it's the unit circle. So what's the radius of the circle? Nope. What's the radius of the unit circle? Unit means 1. So I know you're going with 5 because I told you x over r or whatever, but this is the y-coordinate. It's not the sine or the cosine, it's the y-coordinate. So the y-coordinate is 3/5. The radius of the circle is 1. And so you can see if I make myself a little right triangle like that, then I can use the Pythagorean theorem. X squared plus y squared equals r squared. I don't know what x is. That's what I'm trying to figure out. So I'm going to leave that as x. What's y?
3/5 squared.
3/5, yep. And then I need to square that. And what's r? 1. So I would love to believe that you would be able to finish this from here on your own. I told my calculus class just today, you know from that movie where it says every time a bell rings an angel gets its wings? I told them today, every time a calculus student makes an advanced algebra mistake, an angel dies. Because we were making a lot of advanced algebra mistakes today in calculus. What? Isn't it A Wonderful Life or whatever? It's some is it some Christmas thing? Okay, so x squared we don't know, so I'm going to leave that as x squared. 3/5 squared is 9/25, and then 1 squared is 1. So now, yeah, if I subtract 9/25 from both sides, x squared equals 16/25. And so x equals plus or minus 4/5. How can we tell from where the point is whether it's plus or minus? Sir? Good. And since it's in the second quadrant, that means x has to be negative. Okay, excellent. So that means that the answer is x equals negative 4/5. Okay? Yeah. So before 1, 2, 3, 4 goes around clockwise backwards. So the next one without counterclockwise, yeah, clockwise backwards, same thing, yeah. I put my pants on inside out. That means they're like normal. Okay, you can do the next one then, right? Without drawing the picture and all that crazy stuff. Now they're giving us the x coordinate. So I'm going to go 1/5 squared plus y squared equals 1 squared. Okay, will y be plus or minus if we're in the fourth quadrant? Bless you. It'll be minus. Okay. Okay, so it's the square root of 24 all over 5. But before you throw up the deuces there, young lady, you can simplify the square root of 24. Yeah, so, right, 4 times 6, so then this works out to be 2 root 6 over 5. Okay? I mean, yes. But you didn't deserve this. Yeah, you weren't that close. Okay, any questions on those two?
No.
All right, so let's take a look at the rest of the. So what we can do now, and this is what you guys were talking about. If I know that the cosine is 1 over 7, the 1 is what? X, and the 7 is the radius. Okay, and I'm in the fourth quadrant, so now I'm going to draw a triangle over here, where this is 1 and this is 7. Okay? And then I'm going to use the Pythagorean Theorem to find this side over here. So that means 1 squared plus... Right. So y squared equals 48. So y equals square root of 48. Ty? Shh. What's a number that you know the square root of that goes into 48 evenly? 16. Okay. If you did 4, you're not wrong, but then you'd have to do 4 again. You can just cut to the chase and say 16. So that means this is 4 root 3. Will this be positive or negative? Negative, because we're in the fourth quadrant. So this is negative 4 root 3. So that means the sine is what? Over 7. Because sine is y over r. Cosine is x over r, sine is y over r. We found it. Okay? All right, so now that you have access to that secret knowledge, will you take about 5 minutes to do the last 3 problems on your own? Okay? Shh. Just calm down. What you maybe should have been able to pick up on from the problems that we did together is what's called the Pythagorean Identity. This is the Pythagorean Theorem using sine and cosine instead of instead of x and y. Okay, but you should be able to see from what we did, like I said, that this is going to work out. I'll get them in a minute. Just the same. Okay, that is that cosine squared plus sine squared always equals 1, no matter what the angle is, because sine is, thank you, Erica, sine is the y side of the triangle, cosine is the x part, and the 1 is the radius, okay? So this is basically what we were using to figure out those last problems. It's super important. Like I said, it's up there on the board permanently because it's something that's very useful. And there's a couple of identities underneath there as well that we're going to talk about later in the class. But for right now, you should know and remember. This should be able to, like, I wrote it down, but you just know that sine squared plus cosine squared is equal to 1. Okay? Yeah, this is still 5.3. Okay, so now we can do these problems that we just did a little bit more easily. I think you guys kind of figured this out already. But if we know that sine squared plus cosine squared equals 1, if you know that the sine is 3/7, then that means 3/7 squared plus cosine squared is equal to 1. This is what we were just doing, right? So that gives you 9 over 49 plus cosine squared equals 1. So cosine squared equals 40 over 49. So cosine equals, what's the square root of 40 simplified? 4 times 10, so 2 root 10. And then square root of 49, of course, is 7. And then if we're in the second quadrant, so this guy over here, will the cosine be positive or negative? Negative. because it's the x coordinate. Cosine is the x, sine is the y. They're both alphabetical. All right? So that's what we were just doing in those problems. Yep, cosine's x, sine is y. Waiting. Are any of you guys in physics right now?
Yes.
Yeah. Have you guys done vectors in there? A little bit? A while ago. Okay, because when you did vector resolution, you used this. Yeah, you did. Yep, and then you had to break it down into its x and y components so you could add it together. Right, yeah, so you should be roughly familiar with this, okay? All right, so what we're going to do now is we're going to talk a little bit about how we can find some values for sine and cosine at some special places around the unit circle, okay? And to do this, we're going to do a little geometry review. These are also up in the front of the class here, so if you're not sitting in the front of the room, you're going to want to move so that you can see it. The book goes through some pretty detailed explanation about why this is the case. I'm not going to spend that much time on it. But you learned in geometry that there were two types of extra special right triangles. One is your old friend, the 45, 45, 90. And then the other one is your friend, the 30, 60, 90. Okay? Okay, well, hopefully you'll learn to love this year, or at least not to hate anymore. Maybe we can just get you back to neutral, and then we'll work on some love next year. Okay? I don't know. So if you have a 45, 45, 90 right triangle, you know that this is an isosceles triangle, right? So I'm going to pick the easiest side length that I can for the two legs, which is just 1. And then if I use the Pythagorean theorem to try to find the hypotenuse, then that would give me z squared is equal to 2. So that means that z is equal to the square root of 2. Okay? So in a 45, 45, 90, the sides are always 1, 1, square root of 2. And again, that's on this poster right here behind me. We're going to use that quite a bit. For the 30, 60, 90, this is for you, Cooper. You said you understand a little better when you can see where it came from. Where 30, 60, 90 comes from is that it's half of a isosceles triangle. Okay? So if I make this a 60, 60, 60, and then I can't make this side 1, what did I say? Oh man, and that's recorded for posterity's sake. Woo, yes. Equilateral. Now, technically an equilateral triangle is an isosceles triangle because it does have two equal sides. It's a special, yeah, that's equilateral. Sorry, I meant to say equilateral. Anyway, if I make this whole thing be 2, then how much is this side? 1. How much is this side?
1.
Nope, 2 because it's an equilateral. Duh. So this is 2. And then I have to figure this one out again using the Pythagorean theorem. So I go 1 squared plus y squared equals 2 squared. So 1 plus y squared equals 4. So y equals the square root of 3. I can, no, the Pythagorean theorem works as long as it's a right triangle. So when I cut this in half, then I do get a right triangle. So the sides of a 30, 60, 90 triangle, which again are up here on the board, are 1, 2, and the square root of 3. A little bit trickier because the angles aren't different, so you have to think about which side is across from what angle. But I'm sure that you also remember from your days in geometry that the larger side is across from the larger angle. Okay? So the square root of 3 is across from the 60. All right? Okay, so with that knowledge, then we are able to figure out some fun things like this. Find the coordinates of the point on a circle of radius 6 at an angle of pi over 4. Well, what the heck? Pi over 4, what is that? How do we... Yeah, so we got to change this into degrees by multiplying by 180 over pi. Right, exactly. So the pi's cancel, so you're really just doing 180 divided by 4. So this is 45 degrees. Okay? So if the radius now is 6, and I got a 45, 45, 90. This is a little bit not as fun as when you know one of the legs. But if the radius is 6, then I can call these sides, I don't want to freak you out by calling the up and down one x, but they're both the same, right? So I can go x squared plus x squared equals 36. You okay with that? Okay. So that means 2x squared equals 36. So far, so good. So x squared equals 18. So now if I do my little simplifying the square root game, x equals 3 root 2. Okay? So what are the coordinates of this point right there? How far to the right from here did I have to go to get right underneath this? 3 root 2. How far up did I go? 3 root 2. So the coordinates of that point are 3 root 2, 3 root 2. Okay? So now, I don't know if this is going to be like the next slide or not, but because of this, I can now figure out, without using a calculator, if you use a calculator on a quiz or a test for a problem like this, I will mark it wrong, because all you're doing is just typing it into the calculator, and also the calculator is giving you an approximate answer. What is the cosine of pi over 4? We know that cosine is x over r, right? What's the x coordinate? 3 root 2. What's the radius? 6. So the 3 and the 6 reduce to root 2 over 2. Okay? I just pulled that out of my brain. Okay? What is the sine of pi over 4? Y over r. What's y? What's the y coordinate of this point? Also 3 root 2. And so if those cancel again, and then we end up with root 2 over 2. Okay? So anytime you have a 45, 45, 90, or a multiple of that, so if it was over here, or over here, or over here, then the sine and the cosine are going to be the same, except one might be positive and one might be negative. Okay? Oh, you guys crack me up. I don't know. Didn't we already kind of do this? Angle of 90 degrees. Should we just talk about it anyway? That's dumb. What are the coordinates of that point? 0, 3. Yeah, why would they ask us that ridiculously easy question? All right, moving on. Okay, so then we're into 30, 60, 90. Touched on that already. All right, so this is something that is really important. This is going to save you some trouble because these are the angles that we're going to be messing with a lot. What I'm going to do is I will cut and paste this onto a Word document and I'll print them out and give it to you as notes so you don't have to take the time right now to write it all down. And you can like tape it to the inside cover of your book or something. So these are 0 and 90 we talked about yesterday. Those are the ones right on the x or y axis. That's either 1 or 0, depending on if you want the sine or cosine. And then the 30, the 45, 60, both in radians and in degrees, it gives us the sine and cosine based on the triangles that we just did. No? Is that? Yeah. That's good enough. I'm a lefty. Does that matter? If I catch the woe backwards? I don't know. I don't know, Sydney. I'm old and confused. Okay, so I don't know if you noticed or not, but all of these angles are in between 0 and 90. Obviously, we're going to extend beyond that. And so the way that we're going to do that is we're going to use what's called a reference angle. So we're going to take and we're going to draw a triangle just like this one, but in a different part of the circle. And then we're going to use that triangle to figure out what the x and y are, and then figure out what the sine and cosine are from there. Okay? This, how do you do it? Right hand on the Bible, left hand, or is it the other way around? Right hand on the right hand up, left hand on the Bible. Okay, this I swear is like the most important part of trigonometry for you to be able to understand how to do. It's a pain. There's lots of steps and there's no easy shortcuts. But it's this understanding of being able to take an angle in either radians or degrees and draw the reference triangle and then use the special triangles to figure out what the answer is. This is like good stuff. All right, so here we go. I'm going to find the cosine of 150 degrees and the sine of 150 degrees. So we're putting together all the things we've learned so far in this chapter. I'm going to start at the positive x-axis. I'm going to go 150 degrees, which puts me right about there. Okay? Remember, sorry, it's the Canadian coming through. I grew up in Minnesota, so I have a little, yeah. You knew that. Where do I draw my triangle? Straight down. Okay, we talked about this the other day. You will always draw the reference triangle to the x-axis. It'll either go straight down or it'll go straight up, never across. So if this angle is 150 degrees, what is this one? 30. Everybody catch that? Okay, so this is called our reference triangle because we're not trying to find it for 30 degrees, we're trying to find it for 150, but we're going to use 30 to figure that out. What? Okay, so if this is 30 degrees, how long is the side across from it? Look at the thing on the wall up behind me. What is, not the angle, what is the side?
Shortest.
It's the shortest one, not drawn to scale. What's the side? 1. 1 is across from 30 degrees, okay? Then, as somebody pointed out, this one is 60. So this one is not 2, square root of 3, okay? And this one is 2, okay? One of these sides is incorrectly labeled. Which one and why? No, it's okay. Nope, we're not going to simplify it. We're leaving it as root 3. Which one of these is wrong? Nope. The square root of 3, why? Because it's to the left, so it should be negative. Okay? So that's the only difference between the 150 degree angle and the 30 degree angle. The 30 degree angle would be over here. All the sides would be the same, but they'd all be positive. This one's 150, so that means the x is negative and the other ones are positive. So now I have everything I need to know to figure out the cosine of 150 and the sine of 150. Cosine is x over r. What's the x coordinate of this point? Negative square root of 3. What's the radius? 2. Awesome. What is the sine of 150? That's y over r. What is the y coordinate of this point? 1. So it's 1 over 2 or 1/2. Okay? Okay? That's it. That's the game. And it's a big game and it's an important one, like I said. Huh? Because when I updated the calendar last, there were no golf matches on the website. But a couple of you have mentioned that to me already. I'll try and remember to look after school and put them in there. But it wasn't me. Yeah.
So when I put in sine 150, it gives me 25. And I just like
Do it that way. What do you get when you put in cosine of 150? Does it say that? No. So you can definitely, with your calculator, check and get the easy ones that are like 0, 1, and 1/2. But the square root ones you have to do because it gives you that weird decimal. If you wanted to, you could be like smart and know which one of these comes out to be that. But, you know, that's up to you. Work smarter, not harder, right? Okay, so this gives you the whole deal. This is a very handy chart to have because this is a unit circle with a radius of 1. So if you go back here, if we change this to 1, then we wouldn't have to divide by it, right? So the x-coordinate would be the cosine of that angle, and the y-coordinate would be the sine of that angle. So this circle chart right here is worth its weight in gold. doesn't weigh very much. So for example, if you wanted to know the cosine of 5 pi over 4, you just go over here to 5 pi over 4 on the chart. You look at the x coordinate because cosine is the x, and the answer is negative root 2 over 2. Okay? So yeah, I'll put that on the other chart that I gave you. Okay? All right, so let's do one last one. Find the coordinates of the point on a circle of radius 12 at an angle of 7 pi over 6. What do we do first? Got to change the radians to degrees. I would like to draw it, but I don't know how. I don't know what that is. So I'm going to multiply it first by 180 over pi. What do I get from that? What do I get when I simplify that? 210 degrees. Okay, so now I'm going to draw it. I'm going to make my triangle straight up to the x-axis. How many degrees is this in between my line and the x-axis? 30. And you know that because 180, yep, good, and 210. Okay, so now I can use the triangle on the wall to label the sides. What's this side? 1, because the smallest side is across from the smallest angle. This side is square root of 3, and this side is 2. Okay, who's positive and who's negative? Both of them are negative. Remember that the radius will never be negative. Uh-oh. It said a radius of 12, and I only have a radius of 2. Okay, so I got to multiply everything by 6. Good. So this is actually 12. This is actually negative 6 root 3, and this is actually negative 6. Okay? So what are the coordinates of that point? How far to the left did I go? Negative 6 root 3. How far down? Negative 6. So those are the coordinates of the point. So if I wanted to, they're not asking us to, so I'm not going to. But if I wanted to figure out the cosine, it would be this divided by 12. If I wanted to figure out the sine, it would be this divided by 12. Okay? I am in such a good mood because you guys were such a great audience today. I don't know if it's because Brianna is gone and she's usually so loud. I don't know if it's because Cassidy's gone and she's definitely very loud. Or I don't know if it's because the two smartest people in the room finally decided that they need to just move aside and make things happen. But no, but that means dojo points. What? 7 pi.